Okay, so for 1.4, 1.5 homework 2 and video 2, we have some essential questions to add for day 2. One of them being, what's the calculus limit definition, and I'm just going to abbreviate now, limit definition of a horizontal asymptote. So I'm just going to use HA. So we had what's the calculus limit definition of a vertical asymptote, day 1, and now what's the calculus limit definition of a horizontal asymptote. Second one for today, what are the 3 cases for horizontal asymptotes? New things to think about. That are different from math analysis. So you need to make sure you include, when you're going through this, you already know 3 cases for horizontal asymptotes. But you need to make sure you include what is different and new now that we know calculus and now that we're dealing with some more complicated examples. And the last thing, what's the difference between a limit at infinity and an infinite limit? What causes each? Okay. So what's the calculus definition of a horizontal asymptote? What are the 3 cases for horizontal asymptotes, and what's new now that we're in calculus from math analysis? What's the difference between a limit at infinity and an infinite limit, and what causes each? So then scroll through all your vertical asymptote information, and you will get to horizontal asymptotes. So calculus limit definition of a horizontal asymptote. Horizontal asymptote definition, you will notice, only deals with x going to infinity and x going to negative infinity. Then it talks about horizontal asymptote deals with y equals. And you will notice then y values for limits are what the limit actually equals, what comes out. So you will notice if you want to say that there's a horizontal asymptote at like y equals 5, check the limit as x goes to infinity, as x goes to negative infinity, and you should be getting 5 for one of those. What that means on a graph is that if we want to talk about horizontal asymptotes, I'm going to draw an example with 2 horizontal asymptotes and then also a vertical asymptote somewhere. And you should have seen examples in math analysis where in this middle piece you are able to cross over a horizontal asymptote. But that's kind of weird sometimes for kids because at first when we learn about asymptotes we think we can't ever touch them, we can't ever cross them. And then we start to see some more complicated examples that, hey, wait a second, in the middle I can. Well, why is that? That's because the definition of a horizontal asymptote lets x go to infinity or lets x go to negative infinity. It doesn't have anything to do with these weird random middle x values at like 0, 1, 2, 3, 4, only really, really big to the far right and really, really small to the far left. So if you check those limits, you have 2 limits to check. Always check both x going to infinity and double check what happens when x goes to negative infinity. And if you get limits for either of those or for both of those, you have horizontal asymptotes there. So what that means is that now that we know calculus and we'll deal with some more complicated examples, is it is possible to have two horizontal asymptotes. Okay? Then to some vocab. A limit at infinity is letting x go to plus or minus infinity. And that's what we've just talked about, how we see if we have horizontal asymptotes. An infinite limit is if the answer is plus or minus infinity. That's what we talked about yesterday when we have vertical asymptotes. So vertical asymptotes cause infinite limits. Horizontal asymptotes cause limits at infinity. Okay. So calculus-wise, we are looking at these limits to find out if this original y equals function has horizontal asymptotes. And you have three cases from math analysis. The tricky part or new part here is that math analysis dealt only with rational functions. We can deal with more complicated functions because you know how to take limits. But the basics of what you're used to from math analysis is if degree of numerator, so we're always looking at degree. If numerator is greater when we're looking at degree, then the limits do not exist. There are no horizontal asymptotes. Okay? But if the limits do not exist, that means that you could have an answer of infinity or negative infinity. And so then it tells you you've actually got to think through now which one it's going to be. Okay? Second case, degree, and now if the, oops, I didn't mean to cross that off, I just meant to underline it. If the degree of the denominator is what's greater, then we're looking at the limits being 0. Doesn't make a difference which one I'm approaching, whether I'm approaching infinity or negative infinity, because the 0 plus 0 and minus 0 doesn't make a difference. So no HAs if the degree on top is bigger. If the degree on bottom is bigger, y equals 0 is the HA. Okay? And then if you have, so the top part is just a repeat, but I just ran out of room. So now degrees again, and in this case, degrees are equal. If the degrees are equal, then we make ratios of the leading coefficients. So for those limits, we're going to look at the leading coefficients. And then that also means that that's how we find horizontal asymptotes. This one gets tricky. So there was a little bit to watch for on the last page, thinking through like a positive or a negative infinity. Now there's something to think through. If I end up with a non-rational function, something with radicals, something with fraction exponents, things like that, I better pay really close attention to each one of these limits, because I might get one horizontal asymptote that's at like 2, and I might get another horizontal asymptote that's at negative 2. So I have to really, really pay attention. And if we go back to the last page, we could also highlight we had to pay more attention to when the limits weren't existing. Yeah, the limits weren't existing, but we had to think through to decide if it was going to be infinity or negative infinity. Okay? All right. So those are our three cases from math analysis. We just have to extend them a little bit more now that we will see some more complicated examples and functions. Here is a link, and if you go to Schoology under live links, it's already live and you can click on it. It's got some cars that move along the graphs and show you vertical asymptotes and horizontal asymptotes as far as limits. If you happened, we haven't really talked about it yet in here, but if you happen to ever want a book, we have books we are happy to check out to you if you want them. But if you were to check for this information, the book doesn't put this in chapter 1, they put it in chapter 3. Okay, so for this, we need to pay close attention to what they're asking us. They are asking us to find the horizontal asymptotes. Then, using calculus, so that means I need to check limits. And I went ahead and just typed it for us that we need to check as I go to infinity and as I go to negative infinity every single time. Well, so that we don't have to write it, I went ahead and typed that. But all you would see on a quiz or a test is what's over here on the left that just says find the horizontal asymptotes, and they're going to give you a function. You're going to have to know, oh, hey, that means I have to check these two limits. Okay, so let's do that. We need to decide where we have most of the power. So power greatest, top or bottom. And it's the same for both, whether you're approaching infinity or negative infinity. So I'm just going to kind of write in the middle. Power is greatest on the bottom, in the denominator. So does that mean that you have a horizontal asymptote at 0 at the leading coefficients, or that you don't have a horizontal asymptote at all? Well, if the power is bigger on the bottom, that means you have a horizontal asymptote of 0. There is no need to check the plus minus signs because positive and negative 0 doesn't make a difference. So these limits would each equal 0. If you saw some homework that was just asking you to find limits, you'd have to say, oh, okay, those limits are horizontal asymptote limits. My power is greater in the bottom. That means my horizontal asymptote is 0, and so this limit is 0. But to answer their question, they said find the HAs. So the HA, we don't even have multiple. I don't need an apostrophe S. The HA is y equals 0. It's a horizontal line. Make sure to answer the question that is asked. So in order to support your answer, we use the calculus like they asked us to. But the final answer is what is the horizontal asymptote? And that's what we boxed in with proper notation. The horizontal asymptote is y equals and vertical asymptote is x equals. Okay, again, I'm on the hunt for horizontal asymptotes. We know we have to think through x going to infinity and negative infinity. Now I need to think about the power for this one. In this case, the power is greatest. Again, oops, no, be careful. It looks like in the bottom, but they've put this out of order. Not greatest in the bottom. These powers match. So powers are equal. Okay, so now I'm going to look at leading coefficients. That's the case I'm in when they're equal. So I'm going to do, and I'm going to abbreviate LC for leading coefficient. Leading coefficient ratio is got to be in the form of negative 2/3. Well, I said in the form of because it could end up being one being positive 2/3 and one being negative 2/3. This is a rational function. You have seen these in math analysis. Rational functions behave normally, so they are both negative 2/3. So I can come up here and I know this answer is negative 2/3, and I know this answer is negative 2/3. How you're going to know it's not rational, you're going to see a radical. You're going to see the 3/5 power, something that's a fraction power, something like that. But otherwise, it is a rational function if you have just whole number powers. Okay, we have to answer the question that was asked. The question that was asked is what are the HAs? We only have one. The HA is y equals negative 2/3. Proper notation, this actually answers the question. Okay. Next, as we go through, same sort of thing, analyze the power. So we have power greatest on the top. Okay, if power is greatest on the top, think through your cases from math analysis. That means that you have no HAs. But, so we can easily answer what they've been asking us about HAs. There aren't any. But if I just see these limit questions, I need to know how to answer them too. And so going back to the limits, I could have the limits of infinity or negative infinity. So I need to check each for the signs, because we did make a mention that, hey, this is different from math analysis. Sometimes like one side could go up and one side could go down, and we need to check that. So I know that these are either going to go to infinity or negative infinity because I don't have a horizontal asymptote, but I don't know whether they're going up or down, which one they're going to. So as I want to check that, let's think through. X is going to positive infinity. So X is like 10 billion as kind of a sample number. You're raising it to the fourth power, it's still positive. You're adding 4 to it, it's still positive on top. If x is going to infinity on the bottom, you're cubing it, still positive, multiplying by 3, still positive. This one goes to positive infinity. Still means that the limit does not exist if you want to clarify that. Then, when I come over here to this limit and I let x go to negative infinity, so a sample number like negative 10 billion. Well, negative 10 billion to the fourth power on top, that's positive, because it's an even power. A negative squared is positive. A negative to the fourth power is positive, and so on and so on and so on. But on the bottom, if I take negative 10 billion and I cube it, an odd power with a negative is negative. And so a negative number times 3 is still negative. That means this limit answer goes to negative infinity. Still means the limit does not exist. I'm making us go through all of this because, for one, these limits are your support. This is us using calculus to find horizontal asymptotes. But for two, AP asks you these kinds of limits all the time, and they don't come out and say, hey, this is horizontal asymptote. You need to see, oh, x is going to infinity, that's a horizontal asymptote. You also need to know the flip side of that. If we just say, where are the horizontal asymptotes, you need to know to check both limits. So that's why we're doing all of this for every example. Okay, doing good. I have to analyze the power. And so power greatest, in this case, on top again. And I made us do one on top again, so no HAs. We already established that. But we're going to think through the signs to decide whether it's going to be infinity or negative infinity. And what I changed on this example is that on the bottom, I now have a squared versus a cubed. So I now have even powers both times. Even powers with negatives stay positive anyway. Something squared is positive, something to the fourth power is positive. So even though I'm plugging in negative infinity, I'm going to get a plus on the top and a plus on the bottom. So this is going to infinity, and then we already established this one over here from our last example. But I just wanted you to see a comparison. So a really good Cornell note study question over here on the left side would be like, what's the difference in my answer on 11 and 12 when I have a cube to deal with versus a square? Okay. And as you flip over to the next page for 11 and 12, just some general notes to consider and make sure that we got the point of that. When there are no HAs, you still, to answer the limit question, if that's what AP has asked you. So you know there's not an HA, but they're asking you to find this limit. To answer the limit question, you still have to check or have to think through what happens as x goes to positive infinity versus what happens as x goes to negative infinity, because you might get different answers. One might be a plus and one might be a minus. Okay, one more to practice with this sort of idea, and then we have just a couple generic limits that we'll go through. So what is different here is I'm trying to analyze the power, but now I see a radical, and this is a little bit weird. So we have to remember that the square root of x squared is x. It's technically absolute value of x, but I'm just trying to think about powers here. So the square root of x squared becomes x to the first. So really, if I have that in mind, these powers are equal on top and bottom because I have x to the first for that 5x, and now I really have x to the first because I have the square root of x squared. Okay, if the powers match, so I want to do a leading coefficient ratio for all of our cases of horizontal asymptotes, that's going to be 5 on top and then over the square root of 3, and I can't clean that up, but I'm looking right here. Okay, this is a non-rational function. And this is the first one that we've seen so far. You'll see many more of them. But this is not like math analysis. It's non-rational because of the square root. You didn't do horizontal asymptotes for examples like this, I don't think. So we have to be really close, pay close attention that we're going to check both limits. I might get different answers. Okay, I might end up one time with 5 over square root of 3, and another time I might end up with negative 5. I did a terrible job on that 5. 5 over square root of 3 might be an option, or negative 5 over square root of 3 might be an option, just depending. Okay, so I know I'm going to deal with the 5 over square root of 3. I can go write that down, but leave some space so we can decide if it's positive or if it's negative. Okay, and now as I go through and I think through the signs, x is going to positive infinity here. So positive number multiplied by 5, add 4 on top, that's going to stay positive. On the bottom, positive number, you square it, positive still, multiply by 3, positive still, add to it, again a positive number, so positive still. Square root's not going to change that. So this is positive 5 over square root of 3. Over here, I'm going to negative infinity. Well, 5 times negative 10 billion is negative 50 billion. It's a negative value, and now I'm going to add 4 to it. Well, adding 4 isn't enough to matter, so it's negative. And then on the bottom, but if I take that negative and I square it here, that comes out positive still. Multiplied by 3, add to it, still positive. Okay, so the negative over positive means that's negative overall. So those are the two limit answers, but for what they were asking for us to just find the horizontal asymptotes. So now I have found an example where I have two HAs. Y equals plus or minus 5 over square root of 3. You may want to pull out your graphing calculator. Check in your graphing calculator what this looks like. Graph it. Graph 5x plus 4 over the square root of 3x squared plus x. And verify for yourself that you're getting two horizontal asymptotes. You may not have seen that before. One time when I know you have is in trig class, because you would deal with regular tangent and then you would deal with inverse tangent. And so when you would flip those over, you would get multiple horizontal asymptotes. But otherwise, I don't know if you've seen it before. Those are the basics for horizontal asymptotes, but this last page just gives us some examples of limits, and I need you to think through when you see x going to negative infinity, you immediately need to think, oh hey, that's an HA question. AP is not going to come out and say that. This is kind of hard, I think, with trig, with having the cosine. But let's just go back to something we do know. 1 over x is pretty easy. We have a graph of 1 over x memorized. What happens to that graph? 1 over x goes where as x goes to negative infinity? Well, as x goes to negative infinity, that's out here. 1 over x is approaching 0. So I can do this because I can turn it into the limit as x goes to negative infinity of cosine of 1 over x could really become cosine of 0, and I know that from this information, and I know cosine of 0 because I know my unit circle. Cosine of 0 is 1. So it's not that you have to know what the horizontal asymptote looks like for cosine of 1 over x, but by knowing 1 over x, you can then plug in that value, and then you can find cosine of that value. Okay, this next one, we've seen an example kind of like this with special trig, and we saw that if we didn't quite know what to do, like I have no idea what the graph of that looks like, but I see x going to infinity, so I know I'm thinking HA. But if I don't know what the graph of that piece looks like, let's try some algebra to kind of clean my stuff up a little bit. Let's do x over x plus e to the negative x over x. We saw that in a case for our special trig day. Well, x over x is really convenient. That just goes to 1, and the limit of 1 is 1. And then negative powers, I can send that down. So 1 over x times e to the x. Taking the limit of all of that. Notation-wise, as we're trying to get good at that, when I see this plus sign separating my two pieces, that's why I have to have this bracket here. When I had it as one fraction, I didn't need the bracket necessarily. Okay, limit of 1 is 1, as we talked about. So this is going, that limit's equal to that limit, which is equal to 1 plus, and now I have to figure out this portion. Well, this whole portion goes to 0 because your power is on the bottom. Power is greatest on the bottom. And so the horizontal asymptote connection, if your power is greatest on the bottom, the horizontal asymptote is 0. So even though I don't know what that graph looks like exactly, I know all the powers on the bottom, I know the horizontal asymptote is 0, and then I can add in that 1 that I already had. So you're going to see it both ways. Sometimes the question is just going to say, find this limit. And you're going to have to know if x approaches infinity or negative infinity that I'm really supposed to think through the degrees and decide on my horizontal asymptotes. They're just not telling me that. Then some other times they're going to say, hey, I want you to find the horizontal asymptotes. You're going to have to remember that they're going to give you some tricky ones, and if you don't think through to find both the positive x going to infinity limit and x going to negative infinity limit, then sometimes you're going to miss answers. Sometimes you're only going to give them one horizontal asymptote, but there were really two. And that's a really common student error come multiple choice time. Okay, so that finishes up calculus-wise how we know about horizontal asymptotes. We have two limits to check, and then when we have non-rational functions with square roots or fraction powers, then we really have to think through because it's possible to have several horizontal asymptotes. All right, this is everything for homework 2.